All right, programmers, this is going to be an overview of all of the questions from the final exam, the multiple choice questions. The free response will be in a different video. I'm going to add timestamps into the description, so feel free to use those to jump around to the different questions that you were confused about. This one's going to start with question 1 and go all the way to question 20. All right, so here we go. So question number 1. To figure out in this problem, the variable x, its value as a result of executing the program, taking a look at the answers, it might just be helpful to see how the program works. So in this problem, we can see that x starts out with a value of 2, and then we run this for loop a total of 4 times. And so since we multiply by 3 each time, x is going to be multiplied by 3, 1, 2, 3, 4 times in total. And we can see that this answer down here has exactly that initial value of 2 multiplied by 3, 4 times in total. So in question number 2, we're trying to figure out what a student's course grade is going to be in a class if their lowest test score is dropped. So we drop the lowest individual assignment score, and then we average the remaining scores. So in this problem, using an example is extremely helpful. If the student has 85, 75, 90, and 95, their lowest score of 75 is dropped, and their grade is given to them as the average of the remaining 3 other scores, 85, 90, and 95. Now, in the context of this problem, we're trying to do it using functions. So skipping down to the end, we can see that we're trying to figure out which of the following lines of code can be used to accurately calculate the student's course grade and store it in a variable called final grade. And then we have 1, 2, 3, 4 different options. Now, as a spoiler, this one is the one that's correct. But to get there, I'd recommend that instead of reading through the options, let's construct the lines of code for ourselves. So first things first, we'll see that we can only find the minimum score, the length of all of the scores, or the number of assignments they had, and then to get the sum of all of the scores. So if we're to construct what we have in this example, here, this would be the sum of all the scores minus the minimum score. So the first thing that we'll do is that we'll call sum of scores, and then we'll subtract from that the minimum from scores. And then we divide by 3, which is almost the length of scores. But in this case, the length of scores is 4. So we'll want to divide that not by the length of scores, but by the length of scores minus 1. And that minus 1 represents the 1 score that we're not putting into the average. So let's look for something that looks like this. Min scores subtracted from sum of scores, and then all of that divided by length of scores minus 1. This one divides by length of scores instead of scores minus 1, so that's not right. This one does the division before the subtraction, so that's wrong. This one does the subtraction but doesn't subtract the 1. But this one does the subtraction of min from sum, and then takes that value from final grade and divides it by length minus 1, stores it in final grade, which is why this answer is correct. All right, question number 3. So in this case, we want to determine whether a given score is within 10 points of a given target. So I've taken this idea and I've described it kind of visually here. We're trying to write a Boolean expression that'll return true if our score is between target plus 10 and target minus 10. Excuse me. So let's see. So what we'll want to say is that score has to be greater than target minus 10, and score has to be less than or equal to target plus 10. So here, this one is saying that score has to be greater than target plus 10, but that's not correct. It should be score is less than target plus 10. Here, this one again says score is greater than target plus 10, so that's wrong. This one says score is less than target plus 10, which is good, but it also says that score is less than target minus 10, which is wrong. But here we can say that score is greater than or equal to, or less than or equal to target plus 10 and greater than or equal to target minus 10, which makes this the correct answer. All right, question number 4. So here we're trying to consider, let's see, we're considering this program, which of the following describes the result of executing the program. So in this case, we're trying to figure out what the program displays, and apparently it has to do with even integers, perhaps. The sum of the even integers from 2 to 10 or from 2 to 20. Maybe it's the sum of odd integers from 1 to 19 or 1 to 9. Well, let's figure out what's going on by maybe looking for a pattern in the values of val, sum, and I. So val starts at 0, sum starts at 0, and I also starts at 0. And then for the first time we run through this loop, and by the way, we run through this loop 10 times. Val increases by 2, so val becomes 2, and sum increases by val. So sum has val added to it, so sum is 2 as well. Then I increases to 1, and we run our loop again. I'm just going to take note for the fact that we're going to run this loop 10 times in total. So I, 2, 3, 4, 5, and then finally we'll run it one last time when I is 9. So when I is 2, val increases by 2 again, but now sum increases up to 6. And then val increases to 6, and sum increases to 12. And then val increases to 8, and sum increases to 20. Then val increases to 10, and sum increases to 30. So I'm just going to zoom ahead to the end. And I'm going to think about, well, what's the last value of val going to be? Well, it looks like val is always double I. So when I is 9, val will be 18. 18. Does that seem right? Right. Because we ran this value of 2 when I was 0. And we had this value of 4 when I was 1. So when I is 9, val will be 20. That'll be our last value of val. And since we're always adding these values together, we're adding the 2 and then the 4 on top of it, and then the 6 on top of that, and then the 8 on top of that. We're keeping a running total. It's the sum of all of these even numbers, which is what we saw down here. This program displays the sum of the even integers from 2 to 20. Just to check that it's displaying it, we can see at the end we're displaying the value of sum. We're displaying sum at the very end. All right, question number 5. So in this problem, we're trying to swap the values of alpha and beta, and we're using a temporary variable temp to help us swap their values. We're interchanging them, or swapping. So I'm going to visualize this by using arrows. I'm going to have these arrows pointing from alpha to 3, beta to 5, and temp isn't pointing to anything yet. And at the end of this, what I'm hoping to see when I run each of these lines of code is that alpha will now be pointing at 5 and beta will now be pointing at 3. If that's the case, then we know that the code works. So looking at number 1, first temp is assigned to the value of alpha. So temp looks at 3. Now alpha is assigned the value of beta. So this arrow is changed. Alpha now points at beta. And then finally, beta points at temp. So beta will point wherever temp is pointing, to the 3. And then we end our code and we see that alpha is pointing where beta used to point, and beta is pointing where alpha used to point. So this one is correct. All right, let's try out number 2. So in this case, first temp points to alpha, then beta points to alpha. So we'll get rid of that arrow. And now alpha points to temp. But temp is already pointing to alpha. And so now at the end of this, all 3 of these variables have the same value of 3. That's incorrect. All right, last one. So in this case, first temp points to beta, then beta points to alpha, and then alpha points to temp, which is pointing at the 5, which interchanges their values. So that works well, which means that 1 and 3 together are the ones that work, which is the correct answer to this one. All right, question 6. We're trying to print out the value red, red, blue, red, red, blue, red, red, blue. This is a riveting program. Which of the following code segments can be used to display the intended output? So I put boxes around these, red, red, blue, red, red, blue, red, red, blue, because I'm seeing that this process of printing red, red, blue itself is repeated 3 times. So first I'm going to look for a big for loop that runs 3 times. Here is a for loop that runs twice. So I don't think that that's going to work. And again, here my large for loop runs twice. So I don't think that's going to work. These 2 responses both run a large for loop 3 times. Now, if I look in and see what they do, this for loop will print red twice with an inner for loop running 2 times, my outer for loop running 3 times. This one also has an inner for loop running 2 times and an outer for loop running 3 times. But since this one prints blue inside of its for loop on the inside, this one will print blue, blue, red, and then blue, blue, red, and then blue, blue, red, which is wrong. Whereas our code in this example will print red, red, blue for the first run of that for loop. That's when I is equal to 0. And then when I is equal to 1, it will again print red, red, blue. And then it will do that as well one more time when I is equal to 2. Red, red, blue. So in this case, this is our correct answer here. Question 7. So in question 7, we're trying to write some code that will help us get the correct cost for a museum admission ticket, given an age, either 13 and up for regular or 12 and below for a child, and then also whether or not they're including a guided tour. So there are 3 possible ticket values, 6, 8, and 10. And I'm going to use that to guide how I pick apart the code later on. As I read through each of these, the real question I'm asking myself are, what are the possible values of cost? If I can get 6, 8, and 10, if all 3 of those are possible outputs, then I'll have to take a deeper look at the code and see if it actually works. But if I can't get all 3 of these values, 6, 8, or 10, then I know the code doesn't work. So for example, this first chunk of code initializes cost to 6. And then in certain cases, it increases it by 2. So this means that the only possible values of cost are 6 or 8, because I will never run this line of code again to make it 10. So I immediately know that this doesn't work because I can't get 10, and I should be able to get 10. Down here, let's see. Well, cost starts at 6, and then it's possible to run this chunk of code here to increase it up to 8 if someone's older than 12. And then it's possible to run this line of code and increase it by 2 if someone includes the tour. So it is possible to run neither of those and get 6. It's possible to run just one of those two and get 8. And it's also possible to run all three and get 10. So this looks good. This looks like the answer, and it is, but just to be sure, we can look at the other ones as well. Here in this line of code, or in these lines of code, we start at 6, and then if the age is greater than 12, and if they include a tour, we'll increase by 2. But notice again, it's impossible to ever get 10 as our value of cost, because at most we'll run this line of code here one time. So we know this is incorrect. Down here, let's see. Now, at first, it seems like it's possible to run both of these lines of code, but I want to point out that this is an if-else, which means if we run this line of code here, we will never run this line of code. And so because of that, again, our only possible values for cost are 6 and 8, because we can't ever possibly run both of these lines of code, which means this is wrong too. So since we've ruled out all of those other 3 answers, our instincts that this was the right answer turn out to be true. Okay. Just a quick side note. Since these 2 things are independent, whether or not you whether or not someone is between 13 and up or 12 and below, and whether or not someone is including a tour. Since those 2 things are independent, they don't have to do with each other. That's why in the code we use 2 singular if statements, because those 2 things aren't one or the other. All right. So in this algorithm, we're trying to list out the digits in a number from left to right, or rather from right to left. So if the number is 512, we want to print out 215. So we're trying to figure out a missing step in this algorithm. For a problem like this, I find it helpful to just figure out what the missing step should be for ourselves. So let's read through it. So first we input a positive number, store it a number. Then we divide number by 10, and record the integer quotient and the remainder. The quotient is the quotient with any part of the decimal after it dropped. So our integer quotient for 127 divided by 10 is going to be 12. The remainder is 7. Well, at this point, I know what we should do. We should first print the 7, because that's the first digit. And then we should set number to 12. And then we'll repeat steps 2 and 3 until number is 0. So let's generalize a little bit. 7 was the remainder, so we should print the remainder. And then we'll set the number to the integer quotient, which was given to us by number divided by 10. That's how we got that 12. So let's look for this in one of the answers. Print the remainder, set number equal to number divided by 10. Display the remainder. And then store the remainder in number. That's not quite right. That's close. We should display the remainder, but we shouldn't be storing the remainder. We should be storing the integer quotient. Display the remainder and store the integer quotient in number. So that's what we're looking for. That's our correct answer. Just to check the other ones. This one says display the quotient. No, that's wrong right there. We should be displaying the remainder. And here we display the quotient. Yeah, again, we shouldn't be displaying the quotient. We do want to store the quotient. So I guess it's a little more right than the option before it, but neither of them is completely correct. Our answer is this one right here. Display the remainder and store the quotient. All right. Question 9. So here we're trying to figure out what is displayed as a result of executing the program. So really the question within the question here is, do we run these if statements or not? Excuse me. Well, first we should figure out what's a mod 5. Well, a mod 5 really is going to be 18 mod 5. And in this case, the remainder of 18 divided by 5, well, let's see, 18 divided by 5, that's going to give us 3 with a remainder of 3 as well. Because 5 goes into 18 3 times, so that's 15. Then the leftover bit is going to be 3. So is this greater than 3? Well, no, 3 isn't greater than 3. So we don't print apple, which means we do run this else. Now, is 3 less than 3? No, so we don't print orange, which means we print pear, which is why our answer is pear. All right, question 10. This one's a little tricky. So we have two variables, x and y. They're declared with positive integer values. A third variable is declared and initialized as follows, z, which is x mod y. We want to figure out which one can't be true. Now, I want to remind you of something that has to do with mod. So let's say we're doing x mod 3. So in this case, we're kind of setting y equal to 3, but we'll let x change its value. If we do 0 mod 3, the remainder of 0 divided by 3 is 0. If we do 1 divided by 3, the remainder there is 1. And 2 divided by 3 is has the remainder of 2. But when we do 3 divided by 3, our remainder goes back to 0. 3 divides 3 perfectly. 4 divided by 3 has a remainder of 1. 5 divided by 3 has a remainder of 2. And then we repeat again. 6 divided by 3 has a remainder of 0. 7 divided by 3 has a remainder of 1. 8 mod 3 is 2. 9 mod 3 is 0, and on and on and on. And you see the pattern. 0, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 2. This pattern helps us see why z being equal to y can't be true. This is our answer right here. Because this is the value of z, x mod 3. And 3 is the value of y. And I want to point out that z is always 0, 1, or 2. But it can't be 3, because the remainder of something divided by 3 can never be 3. In the same way, the remainder of something divided by 5 can never be 5, or the remainder of something divided by 4 can never be 4. It's always going to be anywhere from 0 to 1 less than that number. Or another way of generalizing that is to say that z is going to be somewhere from 0 to y minus 1. That's the range of z. But since z can't be y, that's why this one right here cannot be true, and that's our answer. All right, question 11. Here, let's see. Assume that the string variable str has been declared initialized. Which of the following code segments can be used to find the length of our string? So we want to find the length of our string and store it in len. So in code segment 1, we set len equal to 0. And then for I being equal to 0, I is less than stir, I plus plus, we're going to increase len. Now, this is a good idea, but it doesn't work because I being less than stir, well, what we're saying there is int less than string. And this doesn't work in C. This doesn't make any sense. We're comparing two values that can't be compared. So that's why number 1 doesn't work. In number 2, we say, let's have our length be 0, while stir at len is not the null terminator. So while we haven't reached the end of our string, we'll increase len. So let's say that stir is apple. So I'm going to visualize this as an array of chars. And remember that at the end of our array, in a string, only in a string, we're going to have the null terminator. So first, len has a value of 0. And we look at stir at len. Well, first, that's going to be here at our a. And since that's not equal to the null terminator, we increase len. So now len has a value of 1, and we look at the p. Well, that's not the null terminator, so we increase len to 2, and then we look at the p. That's not the null terminator, so we increase to 3, and we look at the l. And then we increase to 4, and we look at the e, and then we increase to 5, and we look at the null terminator. And now those are equal. So we end our code. We leave the while loop. And our last value of len is 5. And that's right. The length of apple, A-P-P-L-E, 1, 2, 3, 4, 5, is 5. So this works. This finds the length of our string. But the same can't be said for number 3. Because number 3, we have the same idea, except here we're looking at stir at I. But notice that there's never a line of code like this. We never say I is equal to I plus 1 or I plus plus or something like that. And so in this case, I stays at 0. And so we have an infinite loop. We'll never reach the end of the string because that first character is never going to be the null terminator unless it's the empty string. So this does not work in every case. In fact, it only works when the string is empty. So 3 doesn't work, which is why our answer is 2 only. All right, question 12. So we're going to assume that this array of numbers nums has more than 10 elements, but we want to find and display the sum of the first 10. Now I've circled lines 5 and 6 because I want to point out the problem with this code. So first we start I at 0, which is going to be giving us the index in nums. And we want to display the first 10 elements. But notice that we immediately increase I by 1. So let's say that nums is something like this, 0, 1, 2, 3, 4, 5, 6, etc. So here is our array. Notice that when we increase I up to 1, when we set I equal to 1 right here, we're saying, look at this index and increase sum by nums at I, which is nums at 1, which means that we skip our first element. We never look at our first element. And since the last value that makes our while loop run is 9, we'll increase that as well by 1. And then our last value will be nums at 10. And nums at 10 isn't in our first 10 elements. We want to look at nums at 0 all the way up to nums at 9. Those will give us the first 10 elements. That's the first 10 elements of nums. And so these two should be swapped. First, we'll want to add that value, nums at I, start at 0, and then we'll want to increase I. That will mean that the first time we run through it, I is 0. And the last time we run through it, I is 9, which gives us the first 10 elements. That's why our answer is that lines 5 and 6 should be interchanged. All right, here we're going to find an error. So we want to run a line of code or some lines of code that will go through 3 strings stored in an array of words called words. And it will give us the number of vowels in those strings. It uses a function getVowels, which accepts a string as a parameter and it returns the number of vowels inside it. So let's look at the code. First, we're going to declare a number of vowels called int num vowels. And this is what we print at the end. We print the value of num vowels. And we run a for loop that runs 3 times in total. And it calls get vowels on each of those values inside of our words array. So for example, words at 0, in this case, that would refer to hello. And then words at 1 would refer to my. And then words at 2 would refer to friend. I'm going to run this function get vowels first on hello, and then on my, and then on friend, which is good. That's what we want it to do. There's a problem here, which is that we never update the value of num vowels. This function returns the number of vowels inside of it, but we don't do anything with that return value. It's like it sends back that value of 2 or 3 or 0. And then that number comes back and just evaporates. It's never used. So what we want to do is to say, instead of get vowels words at I, we want to increase num vowels by that number. We want to say num vowels is increased by the value returned by get vowels. This line of code is what would work. Or more succinctly, we would say that the return value from get vowels is not added to num vowels, so the result remains 0. We never increase num vowels. So that's why our answer is this one right here. All right, question 14. So we have a function called getAverage. It takes 3 integers as parameters and returns their average to the nearest hundredth. We're trying to figure out which of the following function headers is appropriate for getAverage. Well, there are 2 things it needs to do. It takes 3 integers as parameters. And so we can immediately rule out these 2 because they aren't taking any parameters. So what's the only difference between our 2 remaining answers? Well, one has a return type of a float and one has a return type of an int. But they're averaged to the nearest hundredth. That means it has to be a decimal. An example here would be something like 13.24. And well, that is not an int, it's a float, which is why the right answer is float, get average, int A, int B, int C. All right, question 15. A program is run with the following inputs at the command line. What is the data type of argv2? So the data type, what kind of variable is argv2? Well, argv2 is banana. argv2 is banana, and that's a string. Banana is a string, which means that we would have accepted any of these responses. String, capital S string, char star, as well as another way of saying string in C, means it's a pointer to a char. A program is run with the following inputs at the command line. What's the value of argc? So remember, argc is the number of arguments to the command line. So even though the last value of argv, or last index of argv is 4, the total number of arguments is, well, count them, 1, 2, 3, 4. So 4 is our acceptable response for argc. All right, question 17. What command would you type into the terminal to create a new C file called hello.c? So the command that makes a file for you is touch. So you could say just touch, that's okay. What you'd want to type would be touch hello.c, but the command itself is touch. Question 18. What command would you use in the CS50 IO terminal to change from the current directory into a subdirectory named chapter 2? So a subdirectory means that you see it right there. It's immediately below your current directory. So if you typed ls into the terminal, you'd see that chapter 2 was inside of your current directory. And to change directory into chapter 2, you would say cd, change directory, cd chapter 2. All right, question 19. We have a segment of code that's intended to check the first letter of the last command line argument. So as a little reminder, with command line arguments, let's say we had something like /calc 15.3 x 13.1. To specify which command line argument we're talking about, we have to say argv at a certain location. So for example, /calc, that's going to be argv at 0. The next one is going to be argv at 1, argv at 2, and then finally argv at 3 would give us the 13.1. So notice that there are 4 arguments in total. There are 4 arguments. So the value of argc is 4, and our last one is 3. So the pattern here is that our last argument is always going to be argc minus 1, as we discussed in class. Argc is going to give us the number of them. So argc minus 1 is the last index in argv. Now, we want to get the first letter of that last argument. And as a reminder, those are all stored as indices in our array. So if we wanted the first letter of dot/calc, it would be argv0 at 0. So argv0 at 0 means take the first argument dot/calc and then get me its first letter 0. So to say that we want the last command line argument and its first character, we'd say argv3 0. Or more generally, to get the first letter of the last command line argument, we want to say argv at argc minus 1 at 0. And the only line of code that does that is D, argv at argc minus 1 and 0. If that character is alphabetical, we want to print it out. So that's why the answer here is D. All right, last question, number 20. So here, to be eligible to take a certain class in high school, students who are in grade 12 must have a grade point average of at least 3.4. But if you're not in grade 12, you need to have a grade point average of at least 3.7. Which of the following expressions evaluates to true if the student is eligible and false otherwise? So one thing that we notice immediately is that some of these have and some of these have or between the two cases. So let's think about this. Should they both be true? Well, it looks like this case on the left is for 12th graders. And this case on the left is for like 9th through 11th graders. Well, I don't think they should both be true because you can't be both of those things at the same time. So an or makes sense here. An or makes sense because only one of them has to be true. Either you're in 12th grade with a GPA over 3.4, or you're not in 12th grade and you have a GPA above 3.7. So we can rule out these two. Now what's the difference between these other two? Well, it's this, and or. So we can ask ourselves, is this an and or an or situation? Do I need to both be in 12th grade and have a GPA above 3.4? Or is just one enough? Well, no, you have to have both. And so an and in this case is appropriate, which leaves us with the correct answer here. Either you're in 12th grade with a GPA above 3.4, either both of those things are true, or you have a GPA above 3.7. So that's that. If you're looking for the free response question, Mr. Kyung's putting a video together on that one. So you should check out the Canvas page and you should find a video there. Hope this was helpful. Take care.